Hello there, and welcome to the Sleepy Nature Channel. Tonight, we are going to wander gently through one of the most quietly astonishing truths in all of nature. The truth that life, no matter what stands before it, will always find a way. Not loudly, not by force, but with an unhurried, tender, almost dreamlike certainty. Think about a tiny seed resting beneath a slab of concrete. There is nothing above it but weight and gray silence. And yet, one morning, a pale green thread pushes upward, cracks the surface, and reaches toward a light it has never once seen. Or think of a river that has been dammed, rerouted, and redirected. It does not stop. It slows, it rests, it pools. And then, softly, it finds a new way forward, trickling through cracks and stones until it becomes a stream again, and then a river, and then the sea. This is not a dramatic story. There are no heroes, no battles, no urgency. This is a story about the quiet miracle of persistence, of moss, of roots, of wind-carried seeds, of tiny fish navigating new currents. It is a story about how nature breathes and stretches and rests, and then somehow always continues. So settle in now. Let your shoulders drop. Let your breath slow to the pace of the world just before sleep. We have nowhere to be tonight, and all the time in the world to simply listen. Somewhere near the edge of a forest, there is a place where a very old road used to be. You can still see it if you know how to look. A slightly flattened stretch of earth, a gentle straightness in the way the trees grow. But the road itself is gone. It has been swallowed slowly and sweetly by the forest floor. This is where our story begins. Mosses came first. They always do. Moss is one of the gentlest pioneers in the natural world. It asks for almost nothing, only a little moisture and a surface to rest upon. It has no roots, not in the way we usually think of roots. Instead, it clings with tiny thread-like structures called rhizoids, which are less like anchors and more like whispers, a quiet insistence on staying. A single square inch of moss can hold 20 times its weight in water, like a living sponge sleeping on stone. And moss has been doing this for a very long time. Mosses are among the oldest land plants on Earth. They have been growing for more than 400 million years, long before the first dinosaur, long before the first flower, long before the first forest as we know it. When the land was still bare and strange, moss came first and began the slow, patient work of making it ready for everything else. On the old road, the moss came softly, without announcement. It arrived as spores so light they can drift on the gentlest breath of air, invisible to the eye, traveling miles before settling. A spore lands. It waits. Rain comes. And something very small and very determined begins. After the moss came the lichens. A lichen is not quite one thing. It is a partnership, an ancient collaboration between a fungus and an alga. The fungus provides shelter and holds moisture. The alga brings sunlight and turns it into food. They have been living together in this way for hundreds of millions of years, and they have learned to survive in places where almost nothing else can. On bare rock, on Arctic ice, in deserts, on the sides of walls. In one experiment, lichens were placed in the vacuum of space, exposed to full solar radiation. When they were brought back to Earth, they were still alive. On the old road, the lichens crept in slowly, pale gray rosettes, powdery and still, painting the edges of stones with quiet color. They did not hurry. Lichens grow slowly, sometimes only a millimeter a year, but they do not need to hurry. Time is something they understand very well. Beneath all of this, the soil was beginning to change. Every living thing that grows on bare ground eventually adds to the ground itself. It enriches it, softens it, opens it up to water and air. Dead moss becomes part of the earth. Dead lichen becomes part of the earth. The old road was slowly being transformed, not by removal, but by addition, layer by layer, season by season, so slowly you could not watch it happen, but only see the difference if you came back after years. Then the grasses came. Grass seeds, like moss spores, are travelers. They float on wind, cling to the fur of animals, ride inside the digestive systems of birds, and emerge, ready to grow, miles from where they began. One of the most widespread grasses in the world, a grass that grows on every continent except Antarctica, owes much of its success to exactly this kind of easy, effortless travel. It asks only for a little ground. It does not ask for good ground. The first grasses on the old road were thin and pale. They grew in the cracks where the moss had softened the earth just enough. They grew where a bird had rested for a moment and then lifted away. They grew where a deer had passed in winter and left small impressions in the frost. And because grasses are so good at growing, their growing point is at the base, not the tip, which means they can be grazed or cut and simply keep going. They spread. Season after season they spread. If you were to stand on that old road now, you would see what looks like a meadow, a soft, green, gently rustling place. Wildflowers here and there, a daisy, a clover, the pale violet of a field bindweed threading through the grass. In summer, it hums with bees. In autumn, it glows with seed heads, each one a tiny parachute waiting for wind. The road is gone. The forest has remembered. Life has found its way. And tonight, this is the feeling we want to carry with us into sleep. That quiet, unhurried certainty that nothing is too broken to mend, that beneath every still surface, something is gently beginning. Let that thought settle over you now, soft as moss, sure as the turning of the seasons. If this story is bringing you some peace tonight, you might like to leave a little comment below, just a word or two. It means so much to know you are here. And if you have not already, the playlist has other stories waiting for you, just as gentle as this one. Let us move now to a place where the ocean meets the land, to a rocky shore where the tide comes and goes twice each day, covering everything in cold salt water and then pulling back again, leaving the world glistening and still. This is one of the most demanding places to live on Earth. Temperature changes by 20 degrees between low tide and high. The rocks dry out under the afternoon sun and then are hammered by waves. Salt crusts form, then wash away. Most living things would find this impossible. And yet, the tide pools are full of life, so full that when you crouch down and look into one, you find yourself looking into a whole world. The limpet is one of the great survivors of the rocky shore. It is a small creature shaped like a simple cone, pressing itself against the rock with a muscular foot so strong that it would take more force than its own body weight to pull it free. During high tide, the limpet moves across the rock, grazing on algae, thin films of green and yellow that grow so close to the rock's surface they are almost invisible. But when the tide pulls back, and the air grows dry and the sun grows warm, the limpet returns to exactly the same spot it always returns to, its own spot. The rock there has been worn into a perfect impression of its shell over years of returning, and the fit is so precise that it creates a seal, trapping just enough moisture inside to keep the limpet alive through the hours of exposure. A limpet may live in the same small territory, an area no larger than a dinner plate, for 20 years. It knows that territory the way you know the shape of your own home in the dark. Not far from the limpets, in a crack between rocks, lives the common mussel. Mussels hold on with threads they make themselves, thin, golden threads called byssus, which the mussel produces from a gland near its foot. Each thread is attached to the rock with a small disc, and the threads fan out in all directions, like the rigging of a tiny ship. In tests, mussel byssus has been found to be stronger than any synthetic fiber of the same weight, and scientists have spent years studying its chemistry, hoping to learn how to make adhesives that work in water. The mussel does not feed when the tide is out. It closes its shells tightly and waits, patient and still. When the tide comes in, it opens, and tiny hairs called cilia beat continuously, drawing water through the mussel's body, filtering out the microscopic plankton that the mussel lives on. A single mussel can filter up to 50 liters of water in a single day. In the pools themselves, those clear, still pockets of seawater left behind by the retreating tide, there are creatures of remarkable variety. Sea anemones spread their tentacles like flowers in the water, but they are animals, not plants. And those beautiful petals are in fact arms designed to catch small creatures and pull them inward. When the tide goes out, the anemone pulls itself inward, becoming a glossy, wet mound that looks like nothing at all, a small, dark blob on the rock. Then the water comes back and it opens again, and it is a flower again. Sea stars move slowly across the bottom of the pool. They have no brain, no blood, no eyes as we think of eyes, only light-sensitive spots at the tip of each arm that can tell light from dark. And yet, they find their food, they navigate the pool, they right themselves when turned over. They move on hundreds of tiny tube feet, each one ending in a small suction cup. A sea star can pull a mussel shell open using the slow, sustained force of all those tiny feet working together. The mussel is strong, but the sea star is patient. What strikes you most, crouching at the edge of a tide pool, is how complete it feels, how contained, how entire. This small circle of water, this handful of rock, it holds all the drama and beauty and quiet strangeness of the living world. It is everything in miniature. And this is something that nature does everywhere. It fills every available space with life. Not aggressively, not noisily, but with a kind of inevitable completeness. Wherever there is water, light, the faintest possibility of food, something will come, something will stay, something will make a life. Close your eyes for a moment and imagine the tide pool in the evening. The sun is low and golden. The surface of the water catches the light. Somewhere out on the open water, a gull calls once and then is quiet. The world is full and still and perfectly itself. High in the mountains, where the air is thin and cold and the wind moves without pausing, there is a zone that botanists call the alpine. Here, above the tree line, above the last birch and the last juniper, bent sideways by decades of wind, the land opens into something vast and spare. Rock, sky, the slow movement of clouds, and flowers. Alpine flowers are some of the most astonishing things in the natural world. They bloom in colors so vivid, such pure and concentrated pinks and yellows and purples, that they seem almost unreal against the gray stone and the pale sky. And they do it in conditions that most plants would find simply impossible. The edelweiss, one of the most famous of all alpine plants, grows in the cracks of near vertical limestone cliffs at altitudes where the growing season lasts perhaps 8 weeks. Its leaves and petals are covered in dense white hairs, tiny fibers that trap a layer of still air around the plant, acting like a woolen coat against the cold. These same hairs reflect ultraviolet light, which is far more intense at altitude than at sea level, protecting the plant's delicate tissues. The edelweiss is not delicate at all. It is quietly, thoroughly, beautifully armored. The cushion plants are even more extraordinary. These are plants, sometimes dozens of different species, that grow in a low, dense hemisphere, like a tiny living hill pressed against the ground. The cushion form is not accidental. Inside the cushion, the temperature can be 10 or 15 degrees warmer than the outside air. In the wind-blasted heights, the cushion plant creates its own microclimate, a pocket of warmth and stillness in which other, less hardy plants can find shelter. Some cushion plants can live for several hundred years, growing outward at a rate of less than a centimeter per year, patient and circular and ancient. Seeds in the alpine world face a particular challenge. There is not much time. The growing season is short, weeks, not months. So, alpine plants have developed various strategies for using every possible moment. Some keep their seeds inside the parent plant for as long as possible. So, they are already partway developed when they are released. Some have seeds that require a period of freezing before they will germinate. The cold is not an obstacle. It is a signal, a reliable announcement that winter has passed and the brief growing season has begun. Wind is everything in the alpine zone. It carries seeds, shapes plants, determines where snow falls and where it does not, which means it determines where meltwater will be and which patches of ground will be warm enough and long enough exposed to grow anything at all. Plants that grow on the windward side of a ridge are completely different from plants that grow on the sheltered side, even though they may be only meters apart. Every tiny shift in topography creates a different world, and the animals that live here have shaped themselves to fit. The ptarmigan, a bird of the high places, is white in winter and brown in summer. It changes color with the season, matching the bare rock in summer and the snow in winter. Its feet are feathered right down to the toes, like tiny snowshoes spreading its weight on soft snow. In winter, when the cold is most extreme, ptarmigans burrow into the snow itself to sleep, using the same insulating principle as the cushion plant, letting the snow hold their body heat around them. The pika is a small, round mammal, not a mouse, more closely related to the rabbit, that lives among the rocks near the snow line. It does not hibernate. Instead, through summer, it cuts grasses and wildflowers and spreads them out on the rocks to dry in the sun, like a small and industrious farmer making hay. Then it stores the dried grass in chambers between the rocks and lives on this food store through the winter. The pika has been observed to make up to 100 trips in a single day, each one carrying a small bundle of grass in its mouth. When you sit among the rocks of the alpine zone on a summer afternoon, the wind moving slowly over you, the cushion plants dense and green at your feet, a distant ptarmigan calling from somewhere you cannot see, you feel the particular quality of life in a difficult place, not strained or struggling, but intensely present, vivid, as though everything here, having had to work harder to be here at all, glows a little more brightly for it. This might be a lovely moment to share. If you are watching on the channel, consider dropping a like on the video. It helps more people find their way here for a peaceful night. And there are more stories in the playlist, each one a different corner of the natural world to rest in. There is a tree in the American West that can live for 5,000 years. You would not know it to look at it. It is not tall, not grand in the way a cathedral is grand. It is twisted and gnarled, its trunk a slow spiral of living wood and dead wood, its branches sparse and reaching in all directions at once, as though it has spent millennia making up its mind about which way to grow. It is the bristlecone pine, and it lives in the White Mountains of California at altitudes of over 3,000 meters in thin, rocky, alkaline soil that almost nothing else will grow in. And this is precisely why it lives so long. Competition is low. Disease spreads slowly in the cold, dry air. The wood itself is so dense with resin that it resists the fungi and insects that bring down other trees. The very harshness of the place is what allows the tree to persist. The oldest known individual bristlecone pine has been growing since before the pyramids of Egypt were built. It was already old when Rome was founded. It has lived through ice ages, through the rise and fall of civilizations, through centuries of weather and wind and drought and cold. And it is still alive. Still growing, slowly of course. In a single year, a bristlecone pine at high altitude may add only a fraction of a millimeter of new wood, but it adds it, year after year, without pause. Trees know time in ways we cannot quite imagine. A tree does not experience time in moments, in breaths, in the way an animal does. A tree experiences time as accumulation, ring by ring, season by season, layer laid upon layer, in a slow and patient record of every year it has lived. Dendrochronology, the reading of tree rings, is one of the ways we piece together the history of climate on Earth. Wide rings mean a warm, wet, generous year. Narrow rings mean cold, drought, difficulty. A cross-section of an old tree is a library. In forests, trees communicate through their roots and through a network of underground fungi, the mycorrhizal network, sometimes called the wood wide web. A single teaspoon of healthy forest soil contains several miles of fungal threads. These threads connect tree roots to each other, and through this network, trees share sugars and water and chemical signals. Mother trees, the oldest, largest trees in a forest, have the widest root systems and the most fungal connections. And they appear to use these connections to direct more nutrients toward younger trees, particularly their own seedlings. They do not appear to do this consciously. But the effect is real and measurable. Seedlings growing near their mother trees survive at higher rates than seedlings growing alone. When a tree is injured by an insect, by a fungus, by grazing, it releases chemical compounds into the air. These compounds travel on the wind and are detected by neighboring trees, which respond by increasing their their own production of defensive compounds before they are even attacked. Trees warn each other slowly, chemically, silently, but they do. In a forest, the death of a tree is not an ending. It is a beginning. A fallen log becomes a nurse log, a place where new seedlings take root, raised slightly above the competition of the forest floor, nourished by the slow decay of the wood beneath them. In old-growth forests, you can sometimes see a line of trees growing in a perfect straight line, their roots arching up and over the ground, because they all began as seedlings on the same nurse log, now long rotted away. The log is gone, but the trees remain, still carrying the shape of the beginning in the curve of their roots. Let your thoughts slow now, the way light slows in a deep forest. Let the branches of the bristlecone pine, 5,000 years old, rest at the edges of your mind. Patient, unhurried, still growing. You do not need to rush toward anything tonight. You are already here. That is enough. Rain is the oldest story. Before there were forests, before there were flowers, before there were animals on the earth were flowers, before there were animals on land, there was rain. Water falling from clouds, gathering in low places, running downhill toward the sea, lifting again into vapor, traveling on wind, cooling, condensing, falling again. The water cycle is 4 billion years old, and the water falling on your roof tonight may once have fallen on a dinosaur, may once have been part of an ancient sea, may once have floated as a glacier over a land that no longer exists. Rain has a sound that almost nothing else has, a sound that seems to come from everywhere at once, surrounding you, layering itself over silence the way a blanket layers over cold. The sound of rain on leaves is different from the sound of rain on stone, different again from rain on water. On a broadleaf tree, a chestnut or a sycamore, each heavy drop strikes a leaf and sets it trembling, and the trembling sends the water running in thin rivulets to the edge, where it gathers into a larger drop and falls to the leaf below, and then, below that, each leaf channeling the water downward in a slow cascade. By the time the rain reaches the ground beneath a large tree, it has been slowed and sorted and gentled. The smell of rain on dry earth has a name, petrichor. It comes from a compound produced by certain bacteria that live in the soil, actinomycetes, which release their spores when they sense moisture coming. The oil produced by plants and absorbed by clay and rock is also part of it. When rain hits the dry ground, it disturbs these compounds and sends them into the air as tiny droplets, and we breathe them in, and we feel obscurely something like relief. Rainwater that falls on a healthy forest does not simply run off. It soaks into the leaf litter on the forest floor, into the spongy moss and the crumbling wood, and the aerated soil loosened by the roots of trees. It moves slowly downward through layers of earth, filtered as it goes, cleaned by sand and clay and the activities of millions of microorganisms. Eventually it reaches the water table, the underground reservoir of groundwater that fills the spaces between rocks and grains of soil. A forest, in this way, is a slow and living reservoir. It drinks rain and releases it gradually, feeding springs and streams and rivers through long, dry summers. A single large tree can lift hundreds of liters of water from the soil each day, releasing it as water vapor through its leaves, a process called transpiration. In a large forest, this transpiration is so significant that it creates its own rainfall. The Amazon rainforest, for instance, generates what scientists call flying rivers, columns of water vapor that travel through the atmosphere and produce rain hundreds of miles away from where the water originally rose. The forest rains on itself. It sustains its own existence. In the desert, where rain comes rarely, every drop is received with a kind of reverence. The soil crusts over in dry times, a biological crust made of cyanobacteria and algae and fungi, a living skin on the earth that holds the soil in place and absorbs whatever moisture comes. When rain falls on desert soil, it sinks in rapidly at first, then more slowly as the crust swells and closes. Desert plants can absorb through their roots within hours of rain. Some cacti have root systems that extend 20 meters in every direction, but only an inch or two deep, maximizing the surface area that can catch the thin, precious water of a desert shower. After rain in the desert, wildflowers bloom. The seeds may have been waiting for years, dormant, dry, patient, for exactly the right combination of moisture and temperature. And when those conditions finally come, they germinate within hours and race through their entire life cycle in days, sometimes weeks, producing new seeds before the desert dries again. It is a way of living that requires extraordinary patience and extraordinary speed, one after the other. The two things are not opposites, they are partners. Let the sound of rain be with you now, if you can imagine it. Soft and steady, on leaves, on stone, on still water. Let your breathing match that rhythm, in and out, rain and rest. In the spring, in a beech forest, the floor becomes a sea of green, the pale, almost luminous green of new growth, bluebell leaves pushing up through the dark leaf litter, wood anemones opening their white petals to the low, filtered light. This happens before the beeches leaf out, in the brief window when light still reaches the ground in abundance. The woodland floor plants have timed themselves perfectly to use this light before the canopy closes and the shade becomes deep. This timing is not coincidence. Plants measure light and temperature with extraordinary precision. Some respond to day length, the number of hours of light in a day, which is a perfectly reliable signal because it is determined by the Earth's tilt and never varies from year to year. Others respond to accumulated warmth, a certain number of hours above a certain temperature, which is less reliable, but faster to act on. Many use both, checking one signal against the other, the way you might check a clock and also look at the light outside your window. The bluebell is one of Britain's most beloved wildflowers, and it times itself with particular care. Bluebells grow from bulbs, underground storage organs packed with food, sealed against the cold, waiting. When conditions are right, they push up through the cold soil with remarkable speed, their leaves appearing almost overnight, their flower stalks rising within days. A bluebell wood in full flower, a haze of blue-purple beneath gray-barked trees, the air thick with a sweet and faintly wild scent, is one of the most striking sights in the natural world. And it lasts only a few weeks before the canopy closes and the flowers fade, and the energy is pulled back down into the bulb to rest and prepare for the following year. In the ocean, a similar explosion of life happens in spring. The longer days and the warming surface water trigger a bloom of phytoplankton, microscopic algae single-celled plants so small that 1,000,000 of them could fit in a teaspoon of seawater. These tiny organisms multiply rapidly, feeding on the minerals that winter storms have stirred up from the deep, fueled by the growing strength of the spring sun. A spring phytoplankton bloom can double the total number of phytoplankton in the ocean within days. This bloom is the foundation of nearly all ocean life. Zooplankton, tiny animals, the smallest of which are barely visible to the eye, feed on the phytoplankton. Fish feed on the zooplankton. Seabirds feed on the fish. Whales, in some cases, feed directly on the zooplankton, filtering vast quantities of water through the baleen plates in their mouths. Everything connects to that initial explosion of tiny green cells responding to light. On land, spring begins differently in different places, and animals that travel long distances time their arrivals to match the bloom of their particular home. Migratory birds navigate by the stars, by the sun, by the Earth's magnetic field. They carry within them a compass that no one has fully explained, a sensitivity to something invisible that tells them, night after night, which way is home. A bar-tailed godwit, a shorebird, flies from Alaska to New Zealand without stopping. 9 days over open ocean, 11,000 kilometers, without rest, without food. When it arrives, it is lighter than when it left, having burned nearly all its body fat. It rests, eats, and then, months later, flies back. The certainty in that flight is extraordinary. It does not know the route intellectually. It simply knows. The knowledge is in its body, in the tilt of its inner ear, and the sensitivity of its beak to magnetic fields, and the timing of its internal clock that says now, and then now, and then now, moment by moment, across an empty ocean. There are stories here worth sharing. If you are enjoying this one, please do check the playlist. There are nights here for every mood and season, and each one begins where another ends. We are so glad you are here tonight. Underground, a different world is moving. It moves slowly by human standards, slowly enough that you could watch a particular patch of forest floor for an entire year and not see it. But it moves. The soil is alive, more alive by weight than almost any other environment on Earth. A single teaspoon of healthy soil contains more individual living organisms than there are people on the planet. Most of these organisms are invisible. Bacteria, which are among the oldest forms of life on Earth, break down organic material, releasing the nutrients locked inside dead leaves and wood and the bodies of animals, making those nutrients available to plant roots again. Some bacteria fix nitrogen. They take nitrogen from the air, where it is abundant but chemically inert, and convert it into a form that plants can use. Without this process, which happens in the roots of clover and beans and many other plants, the fertility of the soil would slowly drain away. Fungi are the slow architects of the forest. Their fruiting bodies, mushrooms, brackets, puffballs, are only the surface expression of something vast and buried. The main body of a fungus is the mycelium, a network of threads so fine they can thread between individual soil particles, colonizing every available space. Some fungal networks extend over hundreds of acres, connecting thousands of trees. They are so fine that a single cubic inch of healthy soil can contain more than 8 miles of fungal threads. Earthworms are the engineers of the soil. They eat organic material, digest it, and pass it through their bodies, mixing soil layers and aerating the earth as they move through it. Charles Darwin spent 39 years studying earthworms. He concluded that they were among the most important animals on Earth, that without them, the soil as we know it would not exist. A single acre of healthy pasture may contain more than 1 million earthworms, all moving through the earth, their slow passage loosening the soil and opening passages for air and water. Beneath the earthworms, beneath the bacteria and fungi, the rock itself is changing. Slowly, so slowly that a human lifetime contains only the tiniest fraction of the process. Weathering breaks down stone into soil. Water enters cracks in rock, freezes, expands, and forces the crack a little wider. Acids produced by lichens and by rainwater dissolve minerals from rock surfaces. Tree roots grow into cracks, and as the root thickens over years and decades, gradually force the crack apart. What is rock today will be soil in 1 million years, and what is soil today was once rock, once ocean floor, once mountain. The patience of geological time is almost impossible to hold in your mind, but you can feel it sometimes when you put your hand on a warm stone in the afternoon sun. The stone remembers heat differently from the air, holds it more gently, gives it back more slowly. Something in the weight and warmth of stone communicates deep time. This is old, older than memory, older than story, and it is still becoming, still changing, still moving in the unhurried way of mountains and seas. A seed that falls into a crack in a rock does not think about geological time. It simply reaches its roots downward and its shoot upward and grows toward the light that is available to it, and in doing so, opens the crack a little wider, and in 1,000 years, that crack will be a little deeper, and in 100,000 years, it will be a crevice where ferns grow, and in 1 million years, it will be a valley. Life does not override the stone. It simply works with it, patiently, year after year, adding to what is already there. The stone becomes soil, the soil becomes meadow, the meadow becomes forest, and somewhere beneath the forest floor, the stone is still there, still remembering what it was. Let that thought carry you gently. The stone beneath the soil beneath your feet, the deep and patient work of the underground world. Everything is becoming something else, and in the becoming, there is rest. There is a river in Iceland that disappeared. It runs through a lava field from a recent eruption, recent in geological terms, only a few hundred years old, and at a certain point, it simply sinks into the porous black rock and vanishes. Downstream, it reappears, bubbling up from springs, as though it had merely stepped aside for a moment and is now rejoining the journey. Water, perhaps more than anything else, embodies the principle that life finds a way. Water is, in a sense, the original traveler. It does not fight the rock. It goes around it, or under it, or it waits, pooling patiently until the pressure builds and a new path opens. A drop of water falling in a mountain will reach the sea eventually. It may take decades, moving through groundwater and spring and stream and river. It may travel hundreds of miles from where it fell, but it will arrive. The Mississippi River has changed its course dozens of times over thousands of years, shifting, widening, carving new channels, abandoning old ones. What is floodplain today was once the main channel. What was once dry land is now the riverbed. The river is not fixed. It is a living, moving thing, and it responds to every change in the landscape with a patient adjustment, a gentle seeking of the most efficient path downhill. In wetlands, those extraordinary in-between places, not quite land and not quite water, the rules of the river become something stranger and softer. Water moves through wetlands slowly, spreading across broad, flat areas, filtering through dense stands of reeds and sedges. A wetland is not a dramatic landscape. It is subtle and still and full. The reeds stand in the shallow water, their brown seed heads catching the light in winter. The surface of the water is often covered with tiny floating plants. Duckweed, each plant the size of a match head, that turn the water a vivid, improbable green. The reed is one of the most effective colonists in the natural world. It spreads by underground rhizomes, thick, pale stems that push through waterlogged soil, sending up new shoots every few inches. A single reed plant can colonize an area of several meters in a single season. Reeds also spread by seed, their feathery plumes releasing millions of seeds into the wind each autumn. A new wetland, a flooded field, an abandoned pond, a river that has shifted to leave a shallow backwater will be colonized by reeds within years. They will transform it, building up organic matter year by year, gradually raising the level of the ground, until eventually the reeds themselves will be replaced by willows and then by other trees. The wetland will become a carve, a marshy woodland, and then perhaps a proper forest over centuries. This process, the gradual replacement of one community of plants and animals by another, each one making the conditions that allow the next to arrive, is called succession. It is one of the most fundamental processes in ecology, and it is endlessly hopeful. Bare rock becomes lichen, becomes moss, becomes grass, becomes scrub, becomes forest. Flooded ground becomes reed bed, becomes carve, becomes woodland. Every disturbed or empty place is already on its way to becoming something richer. There are animals in wetlands that exist nowhere else. The water vole, a round, brown, velvet-furred creature, digs its burrow in the bank at the water's edge, with some entrances above the waterline and some below. It swims well and dives readily, and it was the inspiration for Ratty in the Wind in the Willows, who famously described messing about in boats as the finest occupation in the world. Water voles eat reed stems and rush leaves and waterside plants, and they are so thoroughly part of the wetland that when wetlands disappear, they disappear too. But when wetlands return, as they are beginning to in parts of the world where people are deliberately reflooding land, reintroducing water to drained fields, the water voles come back. They travel along river systems, finding new habitat, colonizing new reed beds. Life is watching always for an opening. Take a slow breath now and imagine the reed bed at dusk, the orange and gold of the sunset caught in the still water between the stems. A single bird calling somewhere deep in the reeds, the sound of it carrying far in the evening quiet. Feel the stillness of it. You are perfectly safe. You are perfectly still. The water holds the light a little longer than anything else. On a warm summer evening, in a meadow not far from the edge of a wood, the air begins to fill with a sound that is not quite music, but feels like it. The crickets have started. Each species of cricket has its own song, its own precise rhythm and pitch, produced by rubbing a scraper on one wing against a row of teeth on the other. The rate of chirping is related to temperature. A cricket chirps faster when it is warm, and slower when it is cool. Dolbear's law, formulated in 1897, gives a formula by which you can estimate the temperature in Fahrenheit by counting the number of chirps in 14 seconds and adding 40. It is remarkably accurate. The meadow in summer is a world of sound. The grasshoppers produce their dry, scratchy stridulation by rubbing their hind legs against their wings. The bees produce a low hum that you feel in your chest when they pass close. The butterflies are silent. Almost everything about a butterfly is silent, but they move through the air in a way that seems to carry its own quiet. Their wings beat, on average, about 12 times a second, which is slow enough that you can sometimes, on a still day, see each wing beat individually, a slow, deliberate lifting and settling. Butterflies navigate by the sun, adjusting their direction throughout the day as the sun moves across the sky. They have a time-compensated sun compass. They know not just where the sun is, but where it should be at any given hour, which allows them to maintain a consistent direction even as the sun moves. Some butterflies migrate extraordinary distances. The monarch butterfly travels from Canada to a small area of forest in central Mexico, a journey of up to 5,000 kilometers, guided by a compass sense that is calibrated to the sun's position and at night to the Earth's magnetic field. No individual monarch makes the round trip. The return journey is made by their great-grandchildren who have never been to Canada but know somehow how to get there. In the meadow, bees are following their own complex navigation. A honeybee remembers the landscape around its hive in remarkable detail. It can navigate up to 12 kilometers from the hive to find food, and it can communicate the precise location of a food source to other bees through the waggle dance, a figure-8 movement performed on the vertical surface of the honeycomb that encodes direction relative to the sun and distance in the duration of the central waggle run. A dance that lasts 1 second indicates a food source about a kilometer away. A dance that lasts 3 seconds indicates something 3 kilometers distant. The other bees watch, process, and fly out, finding a flower patch they have never seen, guided entirely by the movements of a dancing bee. This is one of the most beautiful facts in nature, that a bee dances to share directions. That information moves through a bee colony, not as chemicals or sounds, but as movement, as a kind of kinetic language. It evolved over millions of years because the flowers were not always in the same place, and the scouts were not always the same bees, and the hive needed a way to turn individual discovery into collective knowledge. In the evening, the meadow quiets. The bees return to the hive as the temperature drops, their legs carrying bright orange loads of pollen. The butterflies find places to roost on grass stems and flower heads, their wings folded together, their body temperature dropping gradually until they are still. The crickets slow their song as the air cools, and the fireflies begin, not everywhere, but in some meadows, on some warm evenings, in certain parts of Europe and North America and Asia. The darkness begins to fill with small, cold lights. Each flash is a signal, a conversation in light. Different species flash at different rates and in different patterns. Some flash once, some twice. Some draw long arcs of light through the dark. A male will flash and then wait for a response from a female resting in the grass, who will flash back after a precise interval that marks her as a member of his species. To watch fireflies is to watch the meadow talking to itself in the language of light. And it is one of the most peaceful things you can do on a warm summer night. If this story is keeping you company tonight, it would be lovely to have you leave a comment, just a word or two about how you are feeling. And if you find yourself wanting more, there are other stories in the playlist waiting quietly for you. In the Namib Desert on the western coast of Africa, the fog comes in from the sea. The desert is one of the driest on Earth. Some areas receive less than 2 centimeters of rain per year. But the cold Benguela current that runs offshore cools the air above it until moisture condenses, and the fog rolls across the coast in the early morning, thick and still and white, and the beetles drink it. The fog-stand beetle climbs to the top of a sand dune before dawn and tilts its body into the wind, its back facing the fog. Its wing covers are covered in tiny bumps, hydrophilic peaks that attract water molecules, and hydrophobic channels between them that let the water run down. The fog condenses on the peaks, the droplets grow, and then they run down the channels to the beetle's mouth. The beetle drinks the desert. This discovery, made in 2001, inspired a generation of engineers and designers who were trying to solve the problem of water collection in dry places. Fog nets, large mesh nets stretched on hillsides in coastal deserts and fog forests, now collect water for communities in Chile, Morocco, and Eritrea, among other places. A single fog net, a few meters square, can collect hundreds of liters of water per day from fog that would otherwise simply pass through. The technology came from watching a beetle. The Namib is full of adaptations this precise and this beautiful. The sidewinding adder moves across loose sand in a series of sideways loops, minimizing its contact with the hot surface and maximizing its speed. The desert-adapted elephant uses its tusks to dig in dry riverbeds, following the underground channels where water still flows beneath the sand. A desert elephant knows where the water is. It remembers across decades of living in the desert where water has been found before, and it returns to those places when drought comes. Elephant calves learn these roots from their mothers and grandmothers, carrying the knowledge forward through generations. Plants in the Namib have found different solutions. The welwitschia is perhaps the strangest plant on Earth. It is a shrub, technically, a gymnosperm distantly related to conifers, but it grows only 2 leaves in its entire lifetime, and those 2 leaves grow continuously from the base, fraying and splitting and splaying out in all directions over centuries. A welwitschia can live for 2,000 years. Some of the plants alive today began growing before the first Viking longships set out from Norway. They collect fog through the thousands of tiny pores on their leaves, supplementing the minimal rainfall with morning moisture. Succulents store water in their leaves and stems, fat, swollen structures whose thick, waxy coating limits evaporation, while their flexible cells expand to hold as much water as possible when rain comes and contract without damage as water is used. A large saguaro cactus can absorb up to 800 liters of water in a single rainstorm, its pleated trunk expanding as it fills. It will live on this reserve for months or years until the next rain comes. The most extraordinary thing about desert life is not that it is sparse. It is that it is so inventive. The The desert presents a problem, a fundamental, basic, apparently insurmountable problem of not enough water, and the living world has responded with hundreds of thousands of distinct solutions, each one precise and particular and entirely its own. Not one solution, but many. Not one beetle, but a whole ecosystem of creatures that have each found a different way to answer the same question. This is what life does with a problem. It does not solve it once and stop. It explores every possible angle, tests every approach, and keeps the answers that work. And the answers that work, it keeps. For generations, for millions of years, until the solution has become so perfect, so fitted to the problem, that it is no longer a solution, but simply a form of being. Rest now for a moment. Imagine the desert just before dawn, the sand still cool from the night, the fog just beginning to drift in from the sea, the beetle at the top of the dune, tilted, patient, waiting, everything still, everything ready, in a deep ocean trench where sunlight has never reached and the pressure would crush a human being instantly. There is life. The hydrothermal vent was discovered in 1977, and it changed what we thought we knew about the requirements of life. These are cracks in the ocean floor, sometimes miles below the surface, through which superheated water rich in minerals is pushed out from the Earth's interior. The water coming out of the vents can be over 400 degrees Celsius, far above boiling at the surface, but not boiling here because of the tremendous pressure. Around the base of these vents, in the darkness and the heat and the chemical-rich water, entire ecosystems thrive. The foundation of these ecosystems is not sunlight. It is chemistry. Certain bacteria, called chemoautotrophs, can derive energy from the chemical reactions between the minerals in the vent water and the cold ocean water around it. They convert this chemical energy into food, just as plants convert sunlight into food. They are the foundation. Everything else grows from them. Giant tube worms up to 2 meters long cluster around the vents. They have no mouth, no stomach, no digestive system. They live entirely on the bacteria that grow inside their own bodies, a compact of symbiosis taken to its extreme. The tube worm provides the bacteria with a home, carries them close to the chemicals they need, and in exchange, the bacteria feed the worm everything it requires. The worm is, in a sense, a farm that tends itself. Pale crabs pick their way across the rocks. Ghostly fish drift at the edges of the vent field. Mussels cluster in beds where the warm and cold water mix. In the darkness, in the heat, in conditions that would have seemed, before 1977, too extreme for any life at all, a whole community lives and feeds and grows and dies and is replaced, cycling nutrients through the deep ocean, invisible to the surface world above. The discovery of hydrothermal vents and their ecosystems made biologists ask seriously about the possibility of life in other parts of the solar system. Europa, one of Jupiter's moons, is believed to have a liquid ocean beneath its icy surface, kept warm by tidal forces from Jupiter's gravity. If there are hydrothermal vents on Europa's ocean floor, and the conditions for them may well exist, then there may be life there too, clustered in the warm water, building its own chemical world in the dark. Life, once started, goes everywhere. It finds the cold, the heat, the dry, the deep, the high, the airless, the acid, the alkaline. Scientists have found microorganisms living in clouds, actually living in water droplets in clouds, cycling through the atmosphere, carried by wind. They have found bacteria that can survive the radiation of space. They have found microbes in solid rock, a kilometer underground, living on the extremely slow chemical reactions of the surrounding geology, with metabolism so slow that they may divide only once every few thousand years. The slowest living things and the fastest, the tiniest and the largest, the most extravagant and the most minimal, all of them are variations on the same theme. All of them are exploring in their particular way what it means to be alive. And what they all share, every one of them, is this: when conditions change, they change too. Not immediately, not in a single generation, but over time, in the patient way of evolution, they find new ways to be. They do not give up. They do not stop. They are life, and life, by definition, continues. This might be a wonderful time to take a long, slow breath, in through your nose, out through your mouth. Feel your body heavy and warm in the place where you are resting. You do not need to do anything. You are held. There is a valley in Japan where the cherry trees bloom, and people have been coming to watch them bloom for more than 1,000 years. The practice is called hanami, flower viewing, and it is one of the most beautiful traditions in the human relationship with nature. People gather beneath the trees when the blossoms are at their peak, which may last only a week, sometimes less, depending on the weather. And they sit together, talking quietly, eating, watching the petals fall. There is something in the Japanese aesthetic called mono no aware, which might be translated as the pathos of things, or the beauty of impermanence. The cherry blossoms are beautiful, partly because they do not last. Their brevity is part of what they mean. The cherry tree does not know it is beautiful. It is not blooming for us. It is blooming because it needs to attract pollinators, bees primarily, and because the warmth and length of the day have reached a particular threshold that signals it is time. The blossoms appear before the leaves because the leaves would shade and cool the flowers, and the tree needs its pollinators to find the flowers easily. The brief, brilliant flush of white and pale pink is a practical strategy, and it is also, accidentally, one of the most moving sights in the world. This is something that nature does again and again. It is beautiful without meaning to be. The colors of a peacock's tail are not art. They are the result of a long and ruthless selection for whatever makes a female peacock most likely to choose a mate. The spirals of a nautilus shell are not mathematics. They are the most efficient shape for growing in all directions while maintaining the same proportions. The iridescence of a hummingbird's throat is not jewelry. It is structural color, tiny platelets in the feathers that refract light, selected because it makes the bird visible to potential mates. And yet, we look at these things and we feel something, not just recognition of beauty, but something deeper, something that quiets the mind and opens the chest, that makes you stop and stay for a moment instead of walking past. This response to natural beauty is so universal, so consistent across cultures and throughout history, that some scientists believe it is not incidental, that there is something in the human nervous system that is calibrated to respond this way to the natural world. Because we evolved in the natural world, and the ability to recognize and respond to health and abundance, and the particular quality of light and sound and color that natural environments produce was itself useful once. When you see a view that makes you catch your breath, a valley lit up in autumn color, a clear night sky full of stars, the sun just reaching the edge of the sea, your body is doing something ancient. You are recognizing, on some level below thought, that this is a good place, a healthy place, a safe place. And the feeling of beauty is the name we give to that recognition. The cherry tree does not know it is beautiful, but you know. And in that knowing, there is a kind of connection, not between you and the tree exactly, but between you and the part of yourself that still knows how to read the natural world. That part has been there a very long time. It is very good at this, and it is glad when you give it something to look at. If this story is settling you gently towards sleep, you might enjoy leaving a like on the video. It helps us keep making more. And in the playlist, there are other evenings waiting for you, just as soft as this one. In the far north, in the months of winter, the sun does not rise. This is the polar night. Days, then weeks, then months of darkness, broken only by the moon and the stars, and sometimes the aurora. The aurora borealis, the northern lights, occurs when charged particles from the sun collide with the gases of the upper atmosphere, exciting the atoms and causing them to emit light. The colors depend on which gas is involved and how high in the atmosphere the collision occurs. Oxygen at about 100 kilometers produces green, the most common color. Oxygen at higher altitudes produces red. Nitrogen produces blue and purple. The lights move because the stream of particles from the sun varies continuously, and the Earth's magnetic field, which guides the particles toward the poles, shifts and pulses with it. The aurora can be almost silent, or it can be accompanied by soft sounds, crackling, humming, that some people hear and others do not, and which have long been disputed by scientists. Recent research suggests these sounds may be real, produced by electrical discharges in the air, occurring sometimes 20 or 30 meters above the ground, far below where the lights themselves are visible. People who live in the far north have always had stories about the aurora. In some Inuit traditions, the lights are the spirits of the dead playing ball in the sky. In Saami tradition, the lights are sometimes spoken of carefully, quietly, not to be too noticed. In Finnish tradition, the word for the aurora, revontulet, means fire foxes, a reference to an old story of a fox running across the sky, its tail brushing the snowflakes up into the colored light. The animals of the north move through the dark months in various ways. Bears sleep through it, their heartbeats slowing to 8 beats per minute, their body temperature dropping only slightly, burning through their stored fat in a slow, warm, biological dream. They are not deeply hibernating. They can be woken, and a mother bear will wake to give birth to her cubs in midwinter, nurse them in the dark den, then go back to sleep. The cubs will be ready to emerge in spring, small and curious, and already full of energy they have borrowed from their sleeping mother. Ptarmigans borrow heat from the snow, burrowing beneath the surface to sleep and escaping the worst of the wind. They change their diet completely with the seasons. In summer, they eat insects and berries and green leaves. And in winter, when nothing green is available, they eat the buds and catkins of willows, a food so bitter and woody that most birds cannot process it. But the ptarmigan's gut is adapted for winter. It actually grows longer in winter and shorter in summer, a remarkable transformation that allows it to extract nutrition from a food source that would be useless to it at any other time. The reindeer has another trick. Its hooves change with the season. In summer, the soft pads of the hooves provide grip on soft, wet tundra. In winter, the pads shrink and harden, and the rim of the hoof becomes more prominent, acting as a snow shovel and an ice grip. One set of hooves, two completely different tools, seasonally deployed. In the frozen dark, the spruce trees are also not entirely still. They have lowered their metabolism to the minimum, drawing water up from deep roots where the ground has not yet frozen solid, moving it through their needles at a rate so slow it is almost nothing. But it is not nothing. The needles are still alive, still green, still ready. When the light returns, and it will return slowly, a minute or two more each day, beginning at the winter solstice, the spruces will be ready. Let the darkness hold you gently now. The polar dark is not empty. It is full of living things resting, conserving, dreaming in their own way, waiting for the light to return. And the light will return. It always does. There is a lake in the mountains, not a famous lake, not a lake with a name you would recognize, but a small, clear lake in the crease between two hills, fed by a spring that comes up through the rock on the eastern shore. The water is so clear that you can see every stone on the bottom, and every stone has a story. Some stones are the remains of mountains that no longer exist. The process of erosion, wind, water, freeze, and thaw, the patient chemistry of rain, takes a mountain and over millions of years reduces it to gravel, to sand, to the fine silt that settles at the bottom of lakes in thin, even layers, one for each year. From these layers, scientists can read the history of the weather, thin layers for dry years, thick layers for wet ones, layers dark with charcoal from fires, layers light with pollen from particular trees. Every year leaves its mark. The lake has been here in this crease between the hills for about 12,000 years, since the end of the last ice age, when the retreating glacier left a basin behind it. In 12,000 years, it has gone through many changes. It has been deeper and shallower, clearer and murkier, surrounded by tundra and then by forest, visited by animals that no longer exist in this part of the world. And yet, it has persisted. The spring still flows. The water is still clear. The stones are still there. Around the shore, willows hang their branches over the water. The willow is one of the most adaptable trees in the world. It can grow from a branch broken off and pushed into mud, a cutting so casual it requires no preparation, no roots, nothing. Push a willow branch into wet ground in spring and come back in summer, and it will be growing. Willows have colonized riverbanks and lake shores this way since the Ice Age ended. A branch carried downstream by a flood, caught on a mudbank, taking root. Moving without moving. The lake's surface is a world of its own. Water striders move across it with the lightness of something that has solved the problem of weight. They distribute their weight across the surface tension of the water, their long legs touching only lightly, each leg leaving a tiny dimple in the surface, but not breaking through. If you lie on your stomach at the edge of the lake and look along the surface at an angle, You can see those dimples clearly, small depressions in the otherwise flat surface, each one a tiny lens catching the light. Beneath the surface, pike hang motionless in the shadow of the willows watching. A pike is the opposite of frantic. It is still, contained, its eyes steady, seeing in nearly every direction at once. When it moves, it is fast, precise, complete. It is an extraordinary piece of engineering, refined over millions of years to do one thing perfectly. Dragonflies patrol the shallows. They are among the most ancient of all flying insects. Their ancestors, which looked much like them, were already flying over wetlands 300 million years ago. A dragonfly can fly backward, sideways, straight up, hover with precise stability, and catch prey in midair. Studies of its hunting patterns show that it does not pursue prey the way most hunters do. It intercepts, calculating where the prey will be, and being there first. It has a success rate of roughly 95%, which is the highest of any predator on Earth. On the evening surface of the lake, the light from the sunset is caught and broken into orange and gold, and the willow branches trail in the water, and a single heron stands at the far shore, still as a post, watching. The heron has been standing there for an hour. It will stand for another hour if it needs to. Patience for a heron is not a virtue. It is simply how a heron is. If you are here tonight and this story is bringing you peace, you are very welcome. And so are others who might need it. Consider sharing it or leaving a like. There is a whole playlist of evenings like this one, each one a different world to rest inside. We come, at last, to the hour before dawn. This is the quietest hour. The night creatures are settling. The owls have made their last flight. The foxes are returning to their dens. The moths are finding their resting places under leaves and bark. The day creatures are not yet awake. The songbirds are still in their night posture, feet gripping the branch, feathers fluffed for warmth, eyes closed. The world is resting. Everything is resting. But there is a sound if you listen very carefully. A single bird in the darkest part of the night, just before the sky begins to lighten. The robin, in many parts of the northern world, sings before any other bird. It sings alone in the dark, its voice thin and clear in the silence. Why? Partly because robins have large eyes for their size, allowing them to see in lower light than most birds. Partly because singing before the crowd is a way of being heard, of establishing a territory with a minimum of competition. The darkness is not a problem. It is an advantage. The robin's song in the dark is one of the most beautiful sounds in the world. It is not beautiful because it is trying to be. It is beautiful because it is true, because it is a small, determined, particular life, announcing itself to the world in the best way it knows how. As the sky begins to lighten in the thin gray hour between night and day, more birds join in. The blackbird comes next, its song fuller and more liquid, a cascade of phrases and pauses. Then the song thrush, which repeats every phrase twice or 3 times, each phrase different, but each repeated with a kind of emphasis, as though to make sure it has been heard. Then the wren, whose voice is startlingly loud for such a small bird. It weighs less than a 10-pence coin, but it sings as though it is the largest thing in the forest. Then chaffinch, robin, great tit, blue tit, dunnock, greenfinch, voice after voice, joining until the air is full of sound, overlapping, rising, the chorus of a whole community waking up. This is the dawn chorus, and it happens every morning, every day of the year, wherever there are birds. In winter, it is shorter and quieter, fewer species, less insistence. In spring, it is longest and most complex, because spring is when territories are being established and mates are being found, and every male bird is singing as much as he can to say, "Here I am. This is my place. Listen to me." For 20 minutes or half an hour, the entire soundscape of a forest is dominated by song. And then the birds begin to move off to feed, and the chorus fades, and the day begins. There is a practice, well established, well loved, of waking before dawn to go out and listen to the dawn chorus. People who do this describe a particular quality of feeling it produces, a sense of being present at something that is not for you, something ancient and continuous and complete, something that would happen in exactly this way, even if you were not there. The world does not need you to witness it to go on being itself. And yet, when you do witness it, something in you is glad. This is what the natural world offers us again and again if we are willing to be still and quiet and patient. Not drama, not sensation, just the slow, steady, certain truth that life goes on, that seeds push through concrete and rivers find new paths and birds sing before the light comes, not because anything guarantees they will succeed, but because they are alive, and being alive is itself the movement forward. The bristlecone pine does not know it is 5,000 years old. The moss on the old road does not know it is reclaiming the ground. The fog-stand beetle does not know it is an inspiration to engineers. The robin does not know its song is beautiful. They simply are. They simply do what living things do. They reach toward what they need. They fill the space available to them. They persist. And so can you. Whatever weighs on you tonight, whatever feels difficult or uncertain or stuck, consider the moss on the concrete, the river finding its way through new stone, the seed in the crack of a cliff face. Not because the comparison solves anything, not because nature is a lesson, but because sometimes it is enough to remember that persistence is the oldest instinct on earth, that the living world has been finding its way through difficulty for 4 billion years, and you are a part of that same world, made of the same materials, animated by the same patient, unhurried will to be here. You are here. That is already something. That is already everything. Let your eyes close now, if they have not closed already. Let your breathing slow to something easier than thought. The robin is singing in the dark somewhere, not for you, and perfectly for you. The moss is growing slowly in the old road. The water is finding its way through the stone. The trees are talking in the dark of the forest, root to root, in a language of sugar and silence. You do not need to do anything. You are held by the same earth that holds the mountains. You are warmed by the same sun that warms the alpine flowers. You are breathing the same air that has moved through the lungs of every creature that has ever lived. Rest now. Life will find its way. It always has. It always will. And so will you. Thank you for being here tonight. This story was made for you.